everyone. Welcome back to another episode of Tuesday Talks with Moat Marine Laboratory and Aquarium. My name is Haley, and I am the event coordinator down here at our International Center for Coral Reef Research and Restoration, located in the Florida Keys. We are interviewing Chelsea Petrik today. She is a staff biologist in our Coral Health and Disease program here at Moat. We are just going to be asking her a couple more questions about her research and how she utilizes the chaos system. So stay tuned. We are going to be diving in shortly. Hi, Chelsea. How are you?
Hi, Haley. I'm good. How are you?
I'm good. Are you ready to get into some questions today?
Mm,
All right,
ready?
perfect. So can you tell us what ocean acidification is, just like a brief description, and why it's a problem or why it's important?
Hey, so before we actually get into what ocean acidification actually is, I want to give you some background information so you have some perspective as we're going through this material. Now, if you think about in modern history, there has been a transition in where the production of goods are occurring. It can be transitioned from your local shops and your homes into these large-scale factories. Now, meanwhile, a lot of these industrial processes are emitting some, yes, naturally occurring compounds like carbon dioxide through the combustion of fossil fuels, but it's been occurring for such a long amount of time that the cumulative effect of these compounds like CO2 have been building up in our atmosphere. And what's unique about our atmosphere and our oceans is that they're heavily interconnected. And so when atmospheric concentrations are reaching a level and they're being far exceeded than ever seen before in history, they're going to be absorbed by the oceans. And so the unfortunate reality is that about 1/3 of those human produced, let's say through industrial processes, those human produced carbon dioxide emissions are going to be uptaken by our oceans, which is a lot.
So when they're uptaken by our oceans, what is going to be a result of that? Do you know?
Yeah, so speaking of seawater, it doesn't really house compounds like carbon dioxide very well. It's a really interesting media. So what will happen is that carbon dioxide will dissociate. It'll break apart to form other compounds and ions in the seawater. And that becomes a problem when there's such a high level of that CO2 being broken apart in our oceans, leading to things like hydrogen ions. And hydrogen ions are linked to pH. And so when you get more hydrogen ions, you're going to be dropping your pH levels and making your waters more acidic. And so that's where ocean acidification is coming from, is when that CO2 from our atmospheres is being taken up and then it's being broken down into other forms of compounds and ions that it really has the most damage. The real problem is that the rate in which these gases are being produced through these industrial processes is that they're not being sequestered naturally by the environment. They're not being broken down into other compounds and being recycled through the earth. So when you have a dramatic increase of these CO2 compounds and they're just lingering in the atmosphere, something's going to happen. And through other practices such as deforestation, without trees to turn that CO2 into something else, and without coral reefs doing similar, you're going to be experiencing a very large change in the concentration of those CO2 compounds in our atmosphere and in our oceans.
So Chelsea works with our chaos system, which is the climate and acidification ocean simulator. Chelsea, that is a beast of a system. So can you just tell us a little bit more about the chaos system?
Sure. The chaos system is a highly specialized aquaria system. What we're doing is manipulating our seawater to simulate different conditions. So we have really intricate and complex machinery that can dose the seawater with CO2 so we can simulate those acidified water conditions. We have heating and cooling apparatus on our system so that if we want to measure the effective temperature, whether it be hot or cold, we can see how different organisms are reacting. Not only can we manipulate things for salinity and for sedimentation and pollution, we have a really flexible system that allows us to experimentally expose, any animals to future projected conditions to see how they're reacting.
that system's like for any animal, really. It's not just coral, which I think is super awesome.
In the past year, we've had some really riveting studies looking at the impacts of OA and heat on corals and urchins, algae, lobsters, and a lot of corals. We're really trying to figure out here at Moat, us scientists are really trying to figure out how corals are going to react to this specifically.
Mm-hmm. Correct me if I'm wrong, but through the resilience testings that you do in the chaos system, that helps us have the high success rate, the over like greater than 90% success rate that we have for our corals that are being outplanted. Is that right, or do I have that wrong?
It's right. We're screening the corals right now. We're screening all the different species and genotypes that we have in our land nursery that do go outplanted onto the reefs for different traits that are basically going to tell us, will they survive through these stressors or were they not? And so as we're screening, we're figuring out how all of the species are kind of interacting with their environment, and that'll help us strategize our outplanting regime. We want corals to be outplanted that will survive on our oceans and in our reefs, and especially live to that age where they'll reach sexual maturity so that they can sustain themselves through reproduction without human involvement anymore.
So Chelsea, you are the coral resilience biologist, correct? So what research are you currently conducting at Moat?
So in light of all these all this discussion about our future projected conditions, the little light is that we're not quite there yet. But what scientists, especially me and my team, are doing are to identify on a cellular, physiological, all the way to a behavioral level of response of these future projected conditions. So a majority of the research that I've done in the last 2 years have been simulating these conditions in aquaria and exposing different keystone or foundation species to the stressors like ocean warming and ocean acidification. Research I'm doing at Moat is figuring out what are these resiliency traits, and to what extent are these traits present in our corals at our facility. In research that I've done in the past, it's looked at the multi-generational aspect of these traits as well. So having, parentals raised in these harsher environments and then having them spawn and reproduce into the next generation, would any of these traits be passed along? And, these are key elements to decipher and to understand their biology and how it's going to be working through, the next 50 to 100 years, not just, right now.
How do you think ocean acidification will be in the future?
When you're talking about acidification, it's going to happen on many different levels. You have your coastal acidification or your oceanic acidification, but nonetheless, those future projected conditions are quite real, and they will happen if nothing is changed. And so I think that when you look at the future, it's best to think about it, how can we avoid getting to that point?
And how do you think people can help prevent us from getting to that point?
First and foremost, really just learning about, ocean chemistry and learning about the repercussions of different processes like industrial processes and what that means for ocean chemistry. So just being educated and getting a perspective that, explains why researchers are going through the rigorous processes of these experiments to figure out what are the impacts. And I think you can also start by looking at your daily life and how you can personally reduce your carbon footprint. And as repeated as that sounds, looking at your own footprint can help you choose better options the next time. Maybe you'll opt for renewable resources instead of finding goods that are being produced and emitting those fossil fuels. So using renewable energy resources is a really great place to start.
So how did you get into this field?
It kind of started in my undergrad. I first got my research experience there, and I worked in aquatic systems, looking at juvenile recruitment in different trees and how urbanization impacted, the recruitment of those trees. And and that sparked my interest working in marine sciences, really. So I went on to work in 3 different nonprofit wildlife conservation organizations before my postgrad, where then I specialized in research looking into ocean acidification and climate change studies. Being so passionate about wildlife conservation, it got me curious to see, and actually wanting to be a part of that process is to figure out what those environmental changes, what impact they would have.
What does a normal day look like for you around Moat?
It just depends on where we're at in our current projects. When we have organisms in research, we'll be tending to the aquaria, doing husbandry, measuring water quality within our seawater. And when we don't really have experiments going on, it'll be looking at the data and interpreting that data to work towards different manuscripts.
Well, I enjoyed talking with you today, Chelsea. Thanks for taking the time to come chat with us and share your knowledge with everyone else.
It's my pleasure. Thank you for having me.
Yeah, until next time. Okay, everyone, that's it for today. I hope you enjoyed this video. If you did and you would like to see more coral content like this, you can find us on our social media channels. We are on Facebook and Instagram at Protect Our Reefs. We also have a Google Classroom that we put education content up on, and we have a new topic every week. If you would like to support our coral reef research and restoration lab in the Florida Keys, we have a specialty license plate. It is called the Protect Our Reefs license plate, and that money comes back to us to help fund our research programs as well as a grant program. Until next time, stay safe and stay healthy. We'll see you guys next week.